Hi students, in the previous class we discussed about analogy between vectors and signals. Vectors and signals. So there we all know when we say that two vectors are orthogonal to each other. Two vectors are orthogonal to each other whenever the dot product is equal to 0. If the dot product of two vectors are equal to 0, then we can say those two vectors are orthogonal to each other. Now, when we say two signals are orthogonal to each other, I already explained you this one in the previous class. So when we say two signals are orthogonal to each other, simply if the integration of, that is the integral of product of two signals over the given interval is equal to 0, then we can say that two signals are orthogonal to each other. The two signals are orthogonal to each other. Simply, if the dot product of two vectors is 0, then we can say that two vectors are orthogonal to each other. In the same way, the integral of product of two signals over the given interval is 0, then we can say the two signals are orthogonal to each other. Mathematically, you can write that one as integral of x1 of t, x2 of t dt over the interval t1 to t2 is equal to 0. Then we can say the signals x1 of t and x2 of t as orthogonal. Here the two signals what I had taken are x1 of t and x2 of t. So the integral of product of x1 of t and x2 of t over the interval t1 to t2 is 0. Then I can say the two signals x1 of t and x2 of t are orthogonal to each other. So this is the condition. I proved this already in the previous class. Now I will do some problems on this condition. So in today's class we are going to solve some problems and we have to prove whether the given signals are orthogonal by using this condition. So in this class we will do 2 or 3 problems based on the time. Okay, now the first one I will give you a problem with two signals as x1 of t value will be equal to 2 and x2 of t value will be equal to root 3 into 1 minus 2t. So I will give two signals as shown. So here I am taking the first signal x1 of t as 2 and the second signal x2 of t as root 3 into 1 minus 2t. So these are the two signals that I had taken and I had to prove these two signals are orthogonal. For that I needed an interval. So here they had given the interval as 0, 1. So these two signals over the interval 0 to 1 are orthogonal. So that we have to prove. So we have to prove the two given signals over the given interval are orthogonal. So the problem is show that the following signals are orthogonal over an interval 0 to 1. The following signals are x1 of t equal to 2 and x2 of t equal to root 3 into 1 minus 2t. So these are the given two signals and this is the given interval. So for this we have to prove or we have to show these two signals are orthogonal to each other. So what we have to do? First we have to go for the integration of the product of the two signals. Integration of the product of the two signals over the given interval. We have to find out this value. If this value is equal to 0, then I can say the given two signals are orthogonal. So that will be equal to according to the problem or according to the given data. So integral, what is the value of x1 of t? 2, right, as 2. And what is the value of x2 of t? Root 3 into 1 minus 2t. So 2 into root 3 into 1 minus 2t dt. Okay. Now next we have to go for the limits. So the interval is, according to given problem, the interval is 0 to 1. So we have to apply the limits as 0 to 1. So solve this equation. Solve this equation. Okay, general mathematical equation. If the answer of this equation is 0, then you can say that two signals are orthogonal. So that will be equal to, what's the value of this one? What's the value of this one? Integral 0 to 1 2 root 3 into 1 is 2 root 3 minus 2 root 3 into 2t. 2 root 3 into 2t. 2 into 2, 4 root 3t dt. So just a into b plus c, a into b plus c, a into b plus a into c. In the same way I expanded it. First thing, again that will be equal to, so for that you can separate those two. Integral of a minus b dt, integral of a dt minus integral of b dt. So you can write like this. So what is the answer? Integral 0 to 1 2 root 3, integral 0 to 1 2 root 3 dt minus integral 0 to 1 4 root 3t dt. Okay, I separated. That will be equal to, what's that one? Integration of constant with respect to t. Integration of constant. 2 root 3 is a constant value. Integration of constant with respect to t. So what was integral of dt is nothing but t. So we can put a constant outside. So what's this one? So the constant 2 root 3, okay, into integral of dt, nothing but t, dt. And the limits are 0 to 1. So this will be up to 0 to 1 minus 4 root 3 is a constant. 4 root 3 is a constant. Okay. Now what is the integration of t dt? Integral t dt. So integral t dt is t square by 2. So integral of x to the power of n, x to the power of n plus 1 by n plus 1. So integral t dt is t square by 2. T square by 2. What do we do? We have to apply the limits 0 to 1. 0 to 1. So that will be equal to, see, that will be equal to, so first apply 1 here. 2 root 3 into 1, nothing but 2 root 3 minus 2 root 3 into 0. Okay, minus, apply 1, t square, 1 square 1. So this is 1 square by 2. So 1 by 2. Okay, it will be given as 4 root 3 into 1 by 2 minus 0 by something is 0. 0 into, okay, 0 into anything is 0. 0 into anything is 0. 0 into anything is 0. Okay, see, this is 1. Now, so for this I am writing like here. For this I am writing here. That will be equal to, what happens? So finally, for what I am finding? Integral t1 to t2 x1 of t x2 of t dt. That will be equal to of this continuation. So a minus 0, a. So 2 root 3 minus 0 is 2 root 3 minus 2 ones, 2 2s. So this is also 2 root 3 into 1. 2 root 3 into 1, that is 2 root 3 minus 0. Simply the value of this one is 2 root 3 minus 2 root 3, which will be equal to 0. So finally what we got? Integral t1 to t2 x1 of t x2 of t dt equal to 0. Or according to our problem, what we got? Integral 0 to 1 2 root 3, integral 0 to 1 2 root 3, integral 0 to 1 2 root 3 into 1 minus 2t dt will also be equal to 0. That is, here integral of product of the two signals or the given interval value is 0. So we can say that the given two signals are orthogonal to each other. So according to this, I can say the two signals are orthogonal. The two signals are orthogonal to each other. So this is our first problem. Okay. Move on to the second one. So the second problem is they had given the two functions sine n omega naught t and cos m omega naught t, and we have to prove they are orthogonal over the interval t naught to t naught plus 2 pi by omega naught, t naught to t naught plus 2 pi by omega naught for the integral values of n and m, for the integral values of n and m. So here small n and small m are integers, integral values of n and m, that is considered as integers 1 2 3 4 like that. Okay, and the given functions are simply, so according to the given problem, what is the given problem? So that the functions sine n omega naught t and cos m omega naught t are orthogonal over the interval t naught to t naught plus 2 pi by omega naught for integral values of n and m. That is the given problem. So we have to show those sine n omega naught t and cos m omega naught t as orthogonal. So for that I am taking as given data. What I have to take? First x1 of t. Consider x1 of t. X1 of t is sine n omega naught t. Next, we have to go for second signal of the second function, that is cos m omega naught t. Cos m omega naught t. First one is x1 of t, that is sine n omega naught t, and next one is x2 of t, that is cos m omega naught t. Okay, so now the given interval is what is the interval? Interval is t naught to t naught plus 2 pi by omega naught. This is the given interval. Okay, so or any interval t naught to t naught plus 2 pi by omega naught. In this interval, the signals x1 of t and x2 of t, that is sine n omega naught t and cos m omega naught t are orthogonal for integral values of n and m. For integral values of n and m, we have to prove this one. So these two signals or these two functions are orthogonal for integral values of n and m over any interval t naught to t naught plus 2 pi by omega naught. So this is the given thing. So simply, where is the formula? We have to go for integration. So what we have to find out? See what we have to find out. First, we have to find out integral. We have to find out integral t1 to t2. We have to find out integral t1 to t2 x1 of t into x2 of t dt. We have to find out this one. So according to the given problem, so this will be equal to integral, what is x1 of t? Sine n omega naught t. Okay, right. What is x2 of t? Cos m omega naught t dt. Cos m omega naught t dt. So we have to write this one, cos m omega naught t dt. Cos m omega naught t dt. Okay. Intervals. Important one is intervals. T naught to t naught plus 2 pi by omega naught. T naught to t naught plus 2 pi by omega naught. So we have to find out the value of this one. So I am writing that again here for your clarification. So I have to find out the value of that one. What is that one? The one is integral t naught to t naught plus 2 pi by omega naught omega naught sine n omega naught into cos m omega naught dt. So we have to find the value of this one and find the value of this one. So for this we need the trigonometric formulas. Okay, so how can you get, let us consider this as A and this as B. What is the formula for sine A cos B? Anyone? I need the formula for sine A cos B. So anyone tell me the formula. So how can you get the formula? First for this I need the formulas of sine of A plus B. Sine of A plus B. So what is sine of A plus B? Everyone know what is sine of A plus B? Sine of A plus B equal to sine A cos B. Sine A cos B plus cos A sine B. So this is the formula for sine of A plus B. So sine of A plus B equal to sine A cos B plus cos A sine B. In the same way, what is the formula for sine of A minus B? What is the formula for sine of A minus B? Anyone? Sine of A minus B will be equal to anyone? Sine of A minus B. Sine A cos B minus cos A sine B. So almost everyone know that one. Okay, everyone know that one. Sine A cos B minus cos A sine B. Okay, so that's the formula. Now, what I need? I need sine A cos B. How can I get? Simply add these two. So I know the sine of A plus B and I know the sine of A minus B. Sine A cos B minus cos A sine B. I rewrite it. Cos at this at the end. So I rewrite it. Now add these two. Add these two. What happens? So if you add these two will get cancelled. So this is some x minus x, that is 0. So this all comes 0. Okay. Now what do you like? Sine A cos B plus sine A cos B. So what is 2 sine A cos B? 2 sine A cos B. So here on the left hand side what will you get? I am adding these two, that is sine of A plus B plus sine of A minus B. Sine of A plus B plus sine of A minus B. So this is the answer for 2 sine A cos B. 2 sine A cos B. But what I need? I need only sine A cos B. From this, what is the formula for sine A cos B? So I need only sine A cos B. Now you tell me the formula for this one. Sine A cos B equal to, bring the 2 this side. So what happens? 1 by 2. So cross this side. 1 by 2 into sine of A plus B plus sine of A minus B. So this is the formula for sine A cos B. This is the formula for sine A cos B. Okay. Now, so using this formula, how can you write this one? Using this formula, how can you write this one? So you have to write the formula for sine n omega naught t cos m omega naught t. Consider this as A. Consider this as B. Sine A cos B. So the formula is, I am writing integral t naught to t naught plus 2 pi by omega naught. So sine A cos B, this is A and this is B. So that will be equal to 1 by 2 into sine of A plus B. Sine of A plus B means sine of, this is A, n omega naught t plus B, m omega naught t. Okay, sine of A plus B. Next, plus sine of A minus B, sine of A minus B, A n omega naught t minus m omega naught t. Okay, this one. So this is the one. Sine of n omega naught t plus m omega naught t plus sine of n omega naught t minus m omega naught t. So your formula sin A cos B equal to 1 by 2 into sine of A plus B plus sine of A minus B. I applied the formula for the given data. Okay, so here by applying this formula I can write the integral of sin n omega naught t into cos m omega naught t as 1 by 2 into sine of n omega naught t plus m omega naught t plus sine of n omega naught t minus m omega naught t. Okay, so I am solving this. T naught to T naught plus 2 pi by omega naught. Okay, here 1 by 2 into, so in this what can I take common? I can take the common as omega naught t. So sine of n plus m omega naught t plus sine, here also I can take omega naught t as common, n minus m omega naught t. Okay, n minus m omega naught t dt. So every time you have to write dt. So you have to write dt. For integration, we have to write dt. Clear? So I have to solve this. So I already told integration of a plus b dt, integration of a dt plus integration of b dt. We can separate them. We can separate them as integral t naught to t naught plus 2 pi by omega naught. So separating that one, what happens? 1 by 2 into sine n plus m omega naught dt plus omega naught dt plus, okay, I am reading this one here I am reading this one, wait. So I am rewriting these equations here. See, so for this how will you write? For this how will write? Integral t naught to t naught plus 2 pi by omega naught. So first of all I can take 1 by 2 as outside, 1 by 2 as outside. Next sine, because 1 by 2 is a constant, I taken as outside, n plus m omega naught t dt plus 1 by 2 integral t naught to t naught plus 2 pi by omega naught sine of n minus m omega naught t dt. See this one. So this is the important one. See here, if you go on solving this, you can get 0 for this one and 0 for this one. So 0 plus 0 completely, that one answer is a 0. So for the given integration, the answer is 0. So we can say the two signals are orthogonal. So the students who are interested to do this, you can do it, or simply you can write a sentence here like that. Now integration of n plus m or n minus m, integration of n plus m or n minus m, full cycles of sine over one period is 0, over one period is 0. So here you can write a simple sentence. Integration of n plus m or n minus m full cycles of sine wave over one period is 0. Full cycle 0. Okay, that means here n plus m full cycles of sine wave over one period is 0. So for this value I can write as 0. Plus here also n minus m full cycles of sine wave over one period is also 0. So the answer will be 0. That is integration of t naught to t naught plus 2 pi by omega naught, that is one period. Sin n omega naught 2 into cos m omega naught t dt will be equal to 0. That is the integration of the product of the two signals over the given interval is 0. So we can say the two signals are orthogonal to each other. So in this we don't need to prove everything. So here you can write this sentence and you can say the value of this one is 0 and the value of this one is 0. Adding the two zeros you get the 0. Or if you are interested, you can do this work at your home. So I am giving this for your practice. Now expand this, and expand this. So on doing the complete integration also, you will get the answers as zeros. So finally you can conclude the two functions are orthogonal to each other over the given intervals. Given interval for integral values of m and n. For integral values of n and m. So this is your second problem. So here what we proved? We proved the given problem. That is sin n omega naught t cos m omega naught t over the interval t naught to t naught plus 2 pi by omega naught are orthogonal for integral values of n and m. So that is we have to consider n and m values as like 1, 2, 3, 4, 5, 6, 7. So this is the integral values of n and m. If you consider only integral values, then only we can get 0. Otherwise we won't get the zeros. For that reason they have given integral values of n and m. Okay. So this is the solving of the second problem and proving that given signals are orthogonal. Given signals as orthogonal. So summary of the today's class. So in this class what we explained. So in this class we had gone for only two problems based which related to the previous topics. So in yesterday's class I had given the formula for when we can say that two signals are orthogonal. So I had given the formula. Based on that formula I did two problems today. Okay. So if you are interested, you can go for the another problem. So I will give you the third problem. So expand this if you are interested, or you can go for the third problem for your work. So I am giving another problem for your work and you can do that at your home. Okay. I shown you two problems to prove how to prove that given signals are orthogonal. Now I am giving you another problem for your work. Okay. So next, the last one is the third one. Prove that the functions xp of t and xq of t, where xp of t and xq of t, where xr of t equal to 1 by root 2 into cos of r omega naught t plus sin of r omega naught t. Okay, and the t value, capital T value equal to 2 pi by omega naught. Capital T value will be equal to 2 pi by omega naught, or orthogonal over the period 0 to t. So this is for your work. So you can do this at your home. So this is for today's class. So we will go for the next topic in the next class. Okay. Thank you one and all.